Alright, well, it took too long in that last video, and I burnt the bottom of the noodles, so those are all stuck to the pan right there. So that will not be fun to clean later. What else? Finished cooking noodles. That's not what I wanted. Here, 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 right here. Here, there, right there. Notice I'm adding some water to those noodles to kind of clean them up a little bit, de-starchify them a tiny, tiny bit. Are they starch? I think. I don't know. No, wait. Starch is like potato. Are those potato? I don't think so. They're rice. Rice? Rice? That's... No, wait. What are those? Wheat? White? White noodles? I don't know. Whatever. I'm cleaning them. I'm doing something. It's too tired. I'm too late. No, I'm too tired. It's too late. See, clearly, I have no idea what's happening. Let's go ahead and finish this problem real quick, because I'm starting to go crazy. Two problems left. Let's see what we got. The length of a rectangular prism is 3 times its width. The volume of the prism is 320 centimeters cubed. Let the variable x stand for the width of the prism. Express the length and the height of the prism in terms of its width x. So let's draw a prism real quick, like that. We're saying the length is 3 times the width. Let's call that the width x. Let's call the length 3 times the width 3x right there. So we know the length is going to be 3x. And what do we know? We know the height, well, we don't. But we know the volume is 320 centimeters cubed. How do you find the volume of a rectangular prism? Well, it's going to be the length times the width, so x times 3x times the height will give you the volume. So solve for h. H has to equal 320 divided by 3x squared. So h right there, we have h equals 320 over 3x squared. And now we're told we want to write an equation that represents the outside surface area of the prism in terms of x. So I wish I hadn't erased my prism. Let's draw it again to help us with this. We have the width x, the length 3x, and the height 320 over 3x squared. So let's go ahead and write the surface area equation. SA will equal, well, what is that side right there? Well, that's going to be the width x times the height 320 over 3x squared. So we're going to have 320x over 3x squared, and there are two of those, front and back. Plus, what about, say, this area right there? Well, that's going to be 3x times the height, so the length times the height. So 3x times 320 over 3x squared. And again, there are two of those, a front and a back. And what about this last bit, the top and the bottom right there? Well, that is going to be the width, x, times the length, 3x. So that's just going to be 3x squared, but again, there are two of them. Now, totally up to you whether or not you simplify this or put it in as is. Maybe if you're on a TI-84, you just want to put it in as is. Maybe if you're on a TI-83, you want to simplify it. It's totally up to you. It doesn't matter. Go through, simplify what you can. So I'm going to simplify some stuff by hand. 2 times 320 is 640. I have that over 3. I have x over x squared. That leaves me an x in the bottom. So 640 over 3x plus, notice in that next term right there, I have a 3x over 3x squared. That just leaves x down there. So I have 2 times 320 is 640 over x plus 2 times 3x squared is 6x squared. So there is my surface area equation. Can you simplify that more? Sure, maybe, kinda, I don't know. I'm not going to, but if you type this into an TI-83, maybe you want to type it as y equals 640 divided by parenthesis 3x parenthesis plus 640 divided by x plus 6x caret 2, or the square button, whatevs. Graph that, find the minimum surface area, and state the dimensions that result in that surface area. If you do Zoom standard, you're going to cry because it's going to look like poop, and you need to figure out what are some realistic x values that make sense for this domain. Well, I may not know specifically, but I do know that x will not be a negative number, so I can start at 0. X max, what would be a good number for a x maximum? Well, the clue is to use the volume. We know the volume is 320, and we know that the width is x and the length is 3x. So think about some numbers that kind of make sense with that. Well, what if x is 10? If x is 10, then think about just 3x times x. That's going to be 3 times 10 is 300. We're already pretty close to our maximum volume. So maybe let's try an x max of 10, and then hit a zoom fit, zoom 0, and see what happens. Well, when you do so, you get a graph that looks like this. You don't really see the bottom. There. You don't really see the bottom. It kind of looks like that. But you do see, whoa, and you see it start to go up a little bit. That's all you need. You just need to see it start to go up, because then we can find that minimum value there, right? Whatever it is. So, second, calculate minimum. Left bound, 0. Why not? Right bound, kind of move it over until it starts going into the positive bit, or just type in 10. That works too. Hit enter, and we find that x is 4.1429. I'm going to write as 3. So x is 4.143, which means our width is 4.143. Before I do anything else, I'm going to see that it says x equals 4.143, y equals 308.9566. I'll write as 957. If that's my width, then 3x, my length, is going to be, will be 3 times that, 12.4289. I'll write as 9. And then the height, which I know is, what did we say the height was? 320 over 3x squared. So 320 divided by, parentheses, 3x squared. And I'm literally typing x on my calculator because it stores that variable for you. The height is 6.214. And what's my volume? Well, my volume, my surface area is that y value, 308.957. And I'm a happy camper. I'm going to go check on my food.